So now let's look at question 5. Sketch the graphs y equals 4 cos x and y equals 2 sine x. Okay. So how am I going to think through this one? Well, that transforms my shapes. So that will multiply the outside, so the output. So instead of 1, it goes to 4, and that instead of 1 goes to 2. So actually my height will go up to top 4 minus 4 here. So 4 minus 4, and I've got my 2 here as well, so I might as well put that in. So I've got my markers like that. It doesn't actually shrink or expand it, so it's simply going to be normal curve, but it says here, this is important as well, it's literally x is less than 180 and equal to or greater than 0. So it's actually at half what you normally get, isn't it? Okay, so now on the classroom, I'm normally quite good at drawing these things. It's half of 1. So remember what cos looks like, remember what sine looks like. The cos one is like that, but it's a half of 1. So it's going to be going like that. And so I'll put a marker in here, put that as 90, that as my 180, and I know, I'll do it in this colour here, that it will look like this. And my sine normally is like that, but it's going to be half of that, so it's literally going to be like this. Okay, and it peaks at the top there, so that's what it's going to look like. So that's that drawn. Right, so now we've drawn it, they say here, find the exact coordinates of the point of intersection. So there we go. And what we're saying is, well, if we know that y equals 4 cos x and y equals 2 sine x, then what we're simply saying is 4 cos x equals 2 sine x. And that's really good. Now, they want it in terms of tan, don't they? They talked about tan. Remember, tan is sine over cos. So I'm going to divide both sides by cos and divide both sides by 2. So if I divide both sides by cos, that becomes tan, and divide by 2. So I end up with 2 equals tan x. So x equals arc tan 2. And that's really important because I think the question asks for the x coordinate to be in that value. Yes, it does. And now it wants the kb, the y coordinate in terms of kb, and this is important. B has to be an integer and k can be rational. Okay, so b's got to be an integer. Now how do we work out what that is? Let's think about this. Tan x equals 2. Remember, tan is opposite over adjacent. So if I just do that over here, it's opposite over adjacent. So that is my tan x. Therefore, if I want it in terms of cos, because don't forget the y value here, they say y equals 4 cos x. So if I want it in terms of cos, cos is going to be adjacent over hypotenuse. So I need to work out what hypotenuse is. Well, that's going to be root 5. So therefore that becomes 4 times 1 over root 5. But what they like is, the question is they want this, the coefficient, the b has to be an integer, and the k can be the fraction, but it has to be rational. So I need to deal with that one there. So I need to rationalize the denominator. So I do that by timesing top and bottom by root 5. This is really the bit that most students would have got wrong in the exam. They would have known what to do here because it is kind of complex. So I end up with 4 over 5 root 5. So my coordinate points, again, don't forget, always leave your coordinates as they want it. That's the question. So you say it's arc tan 2, comma 4 over 5 root 5. And that is good because it wants, it says here k root b, b is that integer, k is rational, and that is rational. That wouldn't have been. There you go. Right, I've just read the part 3, it says the student argues that without this condition of limiting it between 0 and 180, all the points of intersection of the graphs would occur at 360 intervals. Well, I think you can quite easily see that's not going to happen here, because that is going to happen again at this point here, which actually is every 180, and it's 180 degrees because the period of tan x is 180 degrees. So no, it would happen at every 180 degrees because that's the interval for tan x.